Hello friends, I am Kishore. Welcome back to Chennai Robotics platform's Tech Talk featuring Electrofocus 2019 from Jan 31st to Feb 2nd. So Electrofocus 2019 is the annual symposium of the Electronics Department of my college, Madras Institute of Technology, where we conduct many workshops and events where students can participate to win prizes and interns in reputed institutions as well as learn about the current technologies. So for more details, visit www.electrofocus.in and registrations are currently open for workshops like embedded systems, Internet of Things, computer vision and deep learning. So check out this site. So let's get started with today's video. So last week, 2 weeks before, we saw about embedded systems, and last week we saw about Internet of Things, and this week we are going to see about computer vision, and we are going to include the previous technologies too in this video. So what are we going to do in this video? Let's check that out. Friends, welcome to this week's video, and here we have a camera which is mounted on top of a servo motor, and that is connected to a Raspberry Pi, and here we have a live feed of this webcam in my laptop right now. So this feed is coming from the Raspberry Pi to the laptop. And what are we going to do in this project? Okay, now let me demonstrate it to you. Now I'm going a bit backwards. I'm holding a mobile in my hand, as you can see in the feed in the laptop. Okay, so now my face got detected in this image. Now what's happening right now? You can see now that the image is adjusting a bit. How is that possible? So this camera here, which is mounted on top of a servo motor, is controlling the servo motor to bring me to the center of this image. Now what if I go a bit to the right? Now I am a bit away from the center of the image, so the camera, you can see the camera is rotating itself to bring me to the center of the image. So you might have guessed what computer vision exactly is. So computer vision is the power of giving vision to computers. And computer vision requires something called as image processing. So what exactly is image processing? So before that we have to see about image. So an image is a rectangular matrix. So it consists of a width and it consists of a height. So these width and height are measured in terms of pixels. So what exactly is a pixel? So now let's say our dimension of the image is 480 into 640 image. Okay. So the height of the image will be 480 pixels and the width of the image will be 640 pixels. So now one pixel will be the intersection of one row and one column. So now this is one row and this is one column, and the intersection of this is a pixel. So there will be 640 pixels in each row, and there will be a total of 480 rows, and each row is represented by one pixel. Okay. So now what is present inside a pixel? So our pixel will hold three 8-bit numbers. So now our pixel will hold 8 numbers, and each number will lie in the range of 0 to 255. So basically an 8-bit number holds the values from 0 to 255, and we will be having 3 such numbers. So each pixels will represent 3 bytes. So a 100 cross 100 image will have 10,000 bytes, or somewhere around 10 kilobytes. This is approximately. Okay. So what is inside this pixel is these 3 numbers. But what do these 3 numbers represent? So they hold channel values. Okay. So what is a channel? We'll see about that. So we have a B channel, a G channel and an R channel. B channel stands for blue, G channel stands for green and R channel stands for red. And why do we require only 3 channels, and what do these values for each channel means? So we will see that in a visual demonstration. So hello friends, now this is the visual representation of the 3 channels in an image. Now currently the B channel, G channel and R channel hold a value of 0 each, so our color is black. Now let's increase the blue value. As I increase this value, now you can see that the blue color in this image is increasing. Okay, so now let's mix a bit of green to it. So by mixing green to it, now we are getting a different color. Now what will happen if we keep only green as the maximum? Okay, now let's try increasing the red value. Now okay, now by mixing green and yellow, sorry, by mixing green and red, we got yellow color. Now let's mix all the values together. So now we got white. Now let's just mix blue and red together. So we got purple. Now let's have an intermediate values. So now you can see that by mixing blue, green and red, we are able to generate any kind of color which we can see in the physical world. So we only have 3 channels, and these channels will have a maximum value of 255 each. So we can store any color as a 3-byte number. Okay, let's move on to the next section. Okay, now so we know that an image is a combination or a collection of thousands and thousands of pixels, and each pixels will hold 3 values, and by using these 3 channel values and many pixels, we can represent any physical object as an image. Okay, so computer vision requires image processing, and processing more than one image is known as video processing. So a video is a combination of many images one after another. So in video processing, what we will do is we will take one image, we will check for some things, and if some conditions match, so we will do some operations, and then we will move on to the next image, and then we will be repeating the same again and again and again. So in our video, we are going to do face recognition. So we require real-time video. So what we will be doing is, let's just take one image. We will have a webcam, and the webcam will feed us one image, and now let's say there is this face here. Okay, so now how we detect a face is we use something called as R cascades. So R cascade is basically a machine learning file, a file which has been trained to recognize faces in an image. So what we basically do is we will just slide across the image, and once a face is caught in an image, this will return us the coordinates of the image. So now let's call this x comma y, and let's call this x plus w comma y plus h. So now this is w and this is h. Okay, so our face will be in the form of a rectangle. The detected face will be in the form of a rectangle, and the top left coordinate of that rectangle will be in the form of x comma y. So the coordinate system, so in an image has a coordinate system. So now this is 0 comma 0, and this is 0 comma height. So this is the height of the image, and this is the width of the image. So this will be w comma 0, and this will be w comma h. So in this w comma h, so in this image we will be having our top left corner of the image as this x comma y. So what we are doing is we are checking whether the value of x plus w divided by 2. So now let's call this w1 and let's call this w2. So w1 is the width of the whole image and w2 is the width of our image. So this is w2, and w2 divided by 2 will land somewhere around here, and this is our x. So x plus w by 2 will be the center of the face. So we are checking whether the center of the face lies within a region in our image. So this is our total image and our face lies here. So we will check whether it lies between, so our image will be having a width of 640 pixels. So our face should lie somewhere around 270 and 370. If so, the camera is in the right place. But if our face lands somewhere around here, now let's say it is somewhere in 250, so it's too much towards the left. So our camera should rotate like this, so that the face center appears in this region. So if our face is in this place, So the camera should turn in this way so that our face appears in this region. So that's what we will be doing. So let's see how we do that. So now I will tell what was going on in our project in very simple words. So basically we have a servo motor, I will call this S, and we have a camera C. So using this camera, the input from this camera, the output of this servo motor will get varied. Okay. So this is used to control this. That is what is being done in this video. Okay. So how we do that is, this web camera is connected to a Raspberry Pi. So the Raspberry Pi will get the image from the web camera, but for detecting a face in an image, the Raspberry Pi does not have enough processing power. So what we do is, the Raspberry Pi will forward that image to my laptop here. I will call that L. So my laptop will get the image from the Raspberry Pi using local area network connection socket. And for getting the image, the real-time image, we are using something called as CV2 and NumPy. So these are libraries in Python. So CV2 is used for image processing and NumPy is used for matrix multiplications. So any image processing activity requires matrix multiplication. So we will be using NumPy. And the laptop will now detect a face and it will send the position of the center of the face as a string towards the Raspberry. So Raspberry will once again now get this data and now it will check whether the position of the face is in the center. So if it is towards the right, so what now let's say now this is our image and the face has appeared here. So what we have to do is, we have to turn towards the right direction. So for right direction we have a duty cycle of 5% and for left direction we have a duty cycle of 10%. So a duty cycle of 7.5% will make the servo motor point exactly towards the center. A duty cycle of 5% will make the servo motor face in this direction, and a duty cycle of 10 will make the servo motor face in this direction. Okay. So by checking whether the face is present here, here or here, we will be rotating the servo motor accordingly. So that's what is going on in our video, and let's see a practical demo of that. Now actually, before going on to the demonstration, I want to tell you something. Now this Tech Talk is a series which explains about the technologies which are present. So now this is not a series which teaches you the technologies from the scratch. So if you want to learn those technologies from the scratch, you can either attend the workshops in Electrofocus by visiting, or you can wait for a while and subscribe to this channel, because I plan to take tutorials on image processing and deep learning, embedded systems, IoT, everything which you saw in this Tech Talk series, and even more than that. I even plan to teach Arduino and stuff. So if you find the content in this channel interesting, do click the subscribe button and wait for your notifications. Okay, let's move on to the demonstration. Hello friends, now this is the setup for today's video, and here we have a servo motor and a webcam is mounted on top of it, and this webcam is connected to the Raspberry Pi, and Raspberry Pi is powered by this power supply. So this Raspberry Pi and this laptop here are connected on the same network. So what this Raspberry Pi will do is, you will get the feed from this webcam and it will send it over the internet. That is, we have a router there, and the feed from this Raspberry Pi comes over the internet to this laptop, and this laptop will process the feed and it will give instructions to this Raspberry Pi, which in turn will control the servo motor and the camera will rotate hence. Okay. Hello friends, for today's project we basically have two devices which are connected on the same network. So the first device is Raspberry Pi, and the second device is the laptop. Here the Raspberry Pi will act as a server and the laptop will act as the client. So first let us look into the script of the server, that is the Raspberry Pi. So I am using remote desktop to access the Raspberry Pi's code. Now you can see in this code I have embedded the important libraries. So CV2 is for image processing, NumPy is for matrix operations, and this is for controlling the servo motor, and this is to communicate with the device connected on the same network or the global network. Okay. Okay, so now we have made some initializations. So we have initialized the servo motor and we are setting the PWM frequency and the duty cycle at the beginning. And now this is the IP address of Raspberry Pi and we are using port 40,000 and we are establishing Raspberry Pi as the server in these two lines. So now the server will wait for any device to connect with it, and once that happens, this message connected will get printed on the screen, and now we have created a video capture object. So we have connected a webcam to Raspberry Pi and we will get the feed from the webcam using this object cap. So now this phase cascade is actually a trained file. So we actually have used deep learning a bit in this. So this is the trained file. So this will look for faces in an image. So this is not 100% accurate, as you can see, as you saw in our demo video. So this is not 100% accurate, but this will search for faces and it will tell us where the face is present in our video. But that will happen only on the client, that is our computer, because Raspberry Pi is a pretty weak device. It is not uh, good to perform intense mathematical operations on Raspberry Pi because the board will crash and our program will fail. So we are using our laptop to do the processing. So actually this line is not necessary in this Raspberry Pi, but will be useful in the laptop. Okay, so this line will take an image from the camera and now we are encoding the image into a byte stream in these two lines and we are converting it into a string in this line and we are sending that string over the internet to laptop. Okay, so let's see what happens in the laptop. Okay, so this is our script. You can find this code on my GitHub in the description below. So we have done the same in our laptop too. So we have imported socket, we have imported CV2, we have imported NumPy, and this is a function which is used to get the image from Raspberry Pi. So now we are connecting to 192.168.1.1.4, that is Raspberry Pi, and here once again we have the face cascade file which is used for detecting faces in an image. Okay, so if a face is not detected, the default position of the face in the image will be 320. But if any face is detected, so how do we detect the face? So these four lines are first used for obtaining the image from the Raspberry Pi and that will be stored in this frame, and this line will search for faces in the frame and the position of the faces will be stored in this. So we will be accessing them one by one in this for loop and we will calculate the position of the face in these two lines, and this line is used to send the position of the face back to Raspberry Pi. So now why do we have to detect the face in my laptop rather than doing it in the Raspberry Pi? So Raspberry Pi is a pretty weak device, as I said before. It is a pretty weak device. It has to control the servo motor, it has to send the data to the socket, we are using a remote desktop in it, so we are doing so many things, so the Raspberry Pi cannot handle that much processing, so it doesn't have the processing power to do so much processing operations. So instead we will send the image to laptop and the laptop will do the processing for us and we can send it back to Raspberry Pi. So this is in a form, this is in a way cloud computing technique. So this is a cloud computing technique. So instead of processing something in our device, we will be sending our data to a higher device connected to the same network and we will do the processing in that device. So that is cloud computing and Internet of Things which are working together in play. Okay, so now we have sent the position of the face and we can even display the image in our laptop. Okay, so now this line is getting that data which is sent from the laptop, and so now that we have got the position of the face, we will check whether it is greater than 370. So if so, we have to bring it towards the center, so we have to reduce the duty cycle of the servo motor. So by decreasing, the motor will rotate in such a way that I come back to the center. Now if the image is far towards the left, then we have to increase the duty cycle. So by doing that, once again the image will come back to the center. And this is a keyboard interrupt which is used to terminate the script. So hope you have understood this topic very well. So if you have any other doubts, leave a comment in the comment section and we'll see you again in the next video. Bye. Now what if I go a little more to the right? Go a little more to the right. Now once again the image is adjusting itself to bring me to the center. Now what if I go to the left? I'll go a bit to the left. Okay, I've gone out of the image. Okay. Now the camera is once again adjusting itself to bring me to the center. So now this is our project for this week. So if you have any doubts in this video, do leave a comment in the comment section and I will clear them up for you. And if you have any feedbacks and suggestions to improve the performance in my videos, do suggest them in the comment section. So thank you for watching this video. Bye. We'll see about deep learning in the next week and Tech Talks will come to an end with that. Bye.